Okay, so for chemistry today class, we will continue with a new chapter, okay, electrolysis. Okay, let's see what is going on in this chapter. Okay, for the first subtopic, okay, introducing electrolysis. Okay, what is electrolysis? So electrolysis is a process of using electricity to break down or decompose a compound. Okay, electrode. You can see the name electrode, which means electric. Okay, lysis, which means split up, get separate. So the compound is usually molten or dissolved in water. Okay, so this process is important, okay, for extracting useful pure elements from compounds. Okay, as you know, the compounds, is when you have two elements, two different elements combined together, you will form into compound. Okay, that is the meaning for compound. So electrolysis takes place in an electrolytic cell. Okay, as shown in the figure below here, this is known as a electrolytic cell. The electrolytic cell works like an electrical circuit. Okay, this one. Okay, and has these main components. Okay, so you must have the battery. Okay, electrode, these two things, electrode, and you have the electrolyte. Okay, this is the electrolyte. Okay, and this is the connecting wire. Okay, this one is battery, and this one is switch. Okay, where you can switch on and switch off the circuit. Okay, electric circuit. Okay, let's see the what it means by electrolyte. Okay, electrolyte is a molten ionic compound. Okay, as I mentioned last time, ionic compound is when you have metal plus non-metal. Okay, so or an aqueous solution that conduct electricity. Okay, so electrolyte dissociate to form positive ion known as cations, okay, and negative ions, which is known as anions. Okay, so ions present in the electrolyte allow electricity to flow through it. Okay, so example for electrolyte are dilute sulfuric acid, H2SO4, molten sodium chloride, NaCl, and you have copper sulfate solution, CuSO4. This one. Okay, how about electrodes? Okay, electrodes are conduct electric current. Okay, is to conduct electric current. Okay, electrodes are usually carbon. Okay, for example, like graphite. Okay, graphite. Okay, or metal plates. Okay, electrode that is connected to the positive terminal, okay, of the battery is called the anode. Okay, which is this one. Okay, this one is anode. Okay, because this electrode connected to positive terminal, this one. The long line here is known as positive, the short one is here is negative terminal. Okay, the electrode that connected to this one to the negative terminal, okay, for example this one, okay, I pointed here, so it's known as cathode. Okay, this cathode, this one is anode. Okay, so that is the electrodes. Okay, let's see the next one. Okay, how does an electrolytic cell work? Okay, when the circuit is complete in an electrolytic cell, the battery acts as an electron pump, okay, drawing electrons away from the anode, which becomes positively charged. Okay, remove electrons, so the anode become positively charged. Okay, that's why, okay, so they are known as positive, okay, positive charge, okay, this one. So these electrons are supplied to the cathodes, so then they become negatively charged. Okay, so therefore, okay, electrons enter the positive terminal of the battery and are pumped out at the negative terminal. Okay, you can see this diagram. Okay, this one remove electron, then this one will receive electron. Okay, negative, this one negative terminal, this one is positive terminal. Okay, so the electrons enter the positive terminal and then pump out. Okay, remove, okay, goes out at the terminal, negative terminal. Okay, so what happens when electricity is passed through the electrolyte? This is electrolyte, right? So when electricity is passed through this one, an electrolyte chemical reaction takes place at the electrode. This one is electrode. Okay, and the electrolyte is decomposed, split up, okay, separated. The reaction taking place at the electrodes are called electrolytic reactions. Okay, so the next one here, okay, how can electrolysis account for the existence of mobile ions in molten or aqueous ionic compound? Okay, so electrolytes only conduct electricity. Okay, why? Because they contain charged particles. Okay, positively and negatively charged particles. Okay, for example, ions. Okay, that are mobile. Okay, mobile means they can move. So since molten or aqueous ionic compounds can act as electrolytes, they must contain mobile ions. Okay, moving ions. Okay, let's see this one came A. Okay, substances that do not conduct electricity under any conditions are called non-electrolytes. Okay, so which means they do not have any positive and negative charge. Okay? For example, sulfur, sugar, pure water, and organic compounds such as ethanol. Okay, alcohol. Okay, let's see the next page. Alright, so this one. Okay, in the solid state. Okay, in the solid state, which means the ions do not move. Okay, so the ionic compounds do not conduct electricity and thus cannot act as electrolytes. Okay, this is the evidence that the positive ions and negative ions in solid ionic compounds are held fixed in a lattice. Okay, they are held in the positions. Okay, they are unable to move freely and therefore unable to conduct electricity. Okay, remember, in order to have electricity, the charged particle must be moved, moving around. Okay, then you will have electric. Without no, without mobilize, without moving ions, there will be no electricity. Okay, so the next one here. Okay, what are the difference between how elements which is metals and graphite and compound electrolytes conduct electricity? Okay, so metals, carbon, okay, in the form of graphite, and ionic compound when molten or aqueous are all conductor of electricity. Both metals and graphite, okay, are known as electrical conductor, whereas ionic compounds are called electrolytic conductor. Okay, so you have this table, okay, that shows two major differences between electrical and electrolytic conduction. Okay, let's see one by one. Okay, so this one, electrical conduction by metals and graphite. Okay, method of conduction, you can see that, okay, it say electricity is conducted by the flow of electrons. Okay, highlight this one. Okay, flow of electrons can move from one end of the conductor to the other end. Okay, how about electrolytic conduction? Okay, which is by electrolytes. Okay, electricity is conducted by the movement. Okay, movement of positive ions and negative ions. Okay, highlight this one. Movement of positive ions and negative ions across the molten and aqueous electrolyte. Good. So how's the effect? Okay, effect of conduction, metals and graphite remain unchanged. Okay, nothing changed. Okay, chemically when an electric current flows through them. Okay, however, for electrolytes, they are decomposed, split up. Okay, decomposed, which means become positive ion and negative ion. Okay, to form new substance when they conduct electricity. Okay, so there is a difference between electrical and electrolytic conduction. Okay, alright, so the next one here. Okay, so this one is explaining, okay, the process of electrolysis. Okay, second subtopic. Okay, so the process of electrolysis involves three things. Okay, so the first one is the external circuit. Okay, second one, the reactions within the electrolyte. This one. Okay, this one is the external circuit. Okay, you can see the movement of the electron. Okay, and the reaction at the surface of the electrodes. This one. Alright, so let's see the external circuit first. So during electrolysis, okay, electrons flow from the positive terminal to the negative terminal of the battery. Okay, so this one go here like this. Okay, so that's why it's arrow from positive to terminal. Okay, positive to negative terminal. Sorry, okay, from positive to negative terminal. Okay, so let's see the let's say the electrode. What is happening at the electrode? Okay, so during, let's say the anode first. So at the anode during electrolysis, anode is positive. Okay, positive what? Positive electrode. Okay, positive electrode. So during electrolysis, okay, when you have a positive electrode, okay, this one, of course, it will attract, okay, the negative, right? because normally positive and negative they will attract. Okay, if same charges, positive positive, they will repel. Okay, so this one is positive, so of course the negative will attract to the positive one. Okay, so that's why here it say n ions, okay, move to the anode. Okay, n ions give up electrons, okay, get at the anode. So we say oxidation occur at the anode. Okay, oxidation which means, okay, loss of electrons. Okay, how about cathode? Okay, cathode during electrolysis, okay, cations, which is the positive ions, can move to the cathode. Okay, cathode, still remember, is a negative electrode. Negative electrode, so the positive ion will go to the negative electrode, right? Okay, because unlike charges, okay, will attract to each other. Okay, cation receive electron from the cathode, so reduction occur at the cathode. Okay, so how about within the electrolytes? Okay, so during electrolysis, so cations move toward the cathode. Okay, and ions, which is the negative, okay, negative ions move towards the positive electron. Okay, these two have to take note, right? Okay, so the flow of ions towards the electrode, okay, constitute the flow of electric current through the electrolyte. Okay, so this is the explain about the movement of ions and electrons during electrolysis. Can you see the next one? Okay, electrical energy is converted to chemical energy as chemical reactions, okay, which is known as redox reaction, take place at the electrode. So what happens to the ions at the electrode? So as shown in the figure previously, this one, okay, this one figure. So cations, okay, receive cation, which is positive ion, receive electrons from the cathode. Okay, because positive will go to the negative, right? Okay, so an ion, which is negative ions, okay, give up electrons to the anode. Okay, so the process of gaining or losing electrons at the electrodes is called discharge. Okay, take note this one, discharge. So when ions are discharged at the electrode, they form atoms or molecules. Okay, later on we will see some example, right? Okay, so I think I will stop here. Okay, so thank you for today's class.